Hey guys, welcome back. We only have 2 lessons left on linear equalities. Can't believe it, we're almost done with covering the basics. So we got 2 more types of inequalities we're going to be talking about today. Compound inequalities and absolute value inequalities. So today we're going to be talking about compound inequalities. All these. We're going to be learning how to write them, graph them, and then solve them. Alright, so what is a compound inequality? Well, a compound inequality is an inequality with 2 different parts, joined by and or. Ooh, not a inequality, an inequality. Alright, so here's an example of what a compound inequality looks like. Notice that it's got 2 arrows pointing in the same direction. It's got 2 different constants on the sides, and x is in the middle. This would be an example of what we call an and inequality. It could also look something like this. Like this. We won't use this very much, but it is possible that you could end up with inequalities like these to solve. So those are and inequalities. And then or inequalities are always written as this. Alright? So we're going to start things off by learning how to write inequalities. So write and graph inequalities in this form. Alright? So here's a number sense that you might be given. A number x is greater than or equal to 4 and less than or equal to 9. Alright, so number x is greater than or equal to 4 and less than or equal to 9. Alright, so we can write 2 inequalities right here. So we have x is greater than or equal to 4 and x is less than or equal to 9. Alright, now this is an informal compound inequality. Your teachers are probably going to ask that you combine the 2 inequalities together. So to do that, we need to make sure that the arrows are pointing to the left side. That's normally how inequalities are written. We need to flip this first one. And so we will write this as 4 is less than or equal to x, because we flip the sign and we flip the terms over. Then we could combine, then it is true that it can be greater than 4 and less than 9. So you can simply write it as this. Alright? Ooh, I forgot to put in turn on my Paint 3D app. Silly me. Alright, new one. Alright, so I don't have a whole lot of room to draw these kinds of inequalities, but I'm going to do the best I can. Okay? I'm just going to alternate top and bottom here, just so I have the right amount of room. Alright, so we have it's greater than or equal to 4, right? So we need to put a closed circle here, of course, and then it can only go up to 9. So we're going to shade it until we get to 9 and draw a closed circle here. And that, my friends, is the graph of a compound inequality. Alright. Why don't you give it a try? How about a number x is greater than 6, but no more than 8. Why don't you try to work this and try to write this as a compound inequality, and then try to graph it. Alright? So pause the video and try to work this out on your own. Okay, so we have a number x is greater than 6, but no more than 8. Alright? So we're going to write the informal definition for inequality first. And notice that no more means less than equal to. Alright? Remember that the signs need to be pointing in the same direction, so for this first one we are going to flip the terms and the symbol. Now, you will notice I will always have to flip the one that's pointing to the right. In a formal compound inequality, all the symbols must be pointing to the left, not to the right. Alright? It gives a better idea of what part of the number line the inequality represents. Alright? So we have 6 is less than x, which is less than or equal to 8. This one should be much easier to draw for me, okay? Alright, so we have x is greater than 6. And 6. So it cannot be equal to 6. So we need to put an open circle here. And then it can be equal to 8. So we can draw a closed circle here. And then we shade the area in between. Isn't that wonderful? Alright, so that's how you can write and inequalities. Now why don't we try or inequalities? Let's say you have something like this. A number x is either greater than 5 or less than or equal to 0. Alright, so we can write this as two separate inequalities. X is greater than 5, that's an easy one. Less than or equal to 0. And for OR inequalities, we can just leave it as this. Pretty simple. Alright, let's try and graph it. Two, 3, 4, 5. Alright, let's try. 0, 1, 2, 3, 4, 5. Alright, so we have a greater than sign at 5, pointing to the right. We draw an open circle and shade to the right. Alright, and then we have less than or equal to 0, that is a closed circle, shading to the left. Alright, now, what would happen if we actually replaced the OR with AND? Well, I will tell you that the inequality would not make sense at all. Not sense at all. You cannot have a number. You can't have a number that is less than 0 but greater than 5, right? So the inequality is worthless if you replace that word OR with AND. Alright? So if you were to try to graph this inequality, you simply draw it. No shading at all. Alright, so why don't you try one out on your own? Is at least, number x is at least -3, or no more than -1. Why don't you try and graph this out yourself and write it. Alright, so here we are. We have our number sentence. Let's try and write this out. At least -3, that means greater than or equal to -3, or x is less than or equal to -1. Find anything weird about the graph of this? Don't be stumped. Alright. Got to clear sound, so sorry. I didn't fool you or anything, did you? Did I? Did I? Oh, okay, I'm sorry. Well, if you did, and you got something like this, well then, I will tell you that you actually got it right. Right. Now notice that everything to the left of -3 here is not true, but everything to the left here is true. Number 2. If we were to replace this word OR with AND, then really, we just have this middle part shaded. Shade. But since we have a point to the left side pointing to the shaded to the right, and then a point on the right side shaded to the left, they cross each other and going in opposite directions. So this is actually a case. This is actually an inequality that has an infinite solution set, where all real numbers are solutions to this inequality. Pretty weird, huh? And speaking of solutions, are we ready to solve them? I hope so. Alright, so let's try this first one here. So we have 3 is less than or equal to 3x minus 4 is less than 7. So, like with any other inequality that we are supposed to solve, we have to get x by itself. In order to do that, we must use inverse operations, like we've been using since the beginning of the year. Alright, so we add 4 to each side. Ugh. You know how good I am with creating fractional solutions to equations and inequalities that I created on my own? Very good, can't you tell? Alright, well anyways, if you were to solve this, this is what you would get. Alright. So 7/3 is less than or equal to 3x, it's less than 11. Ooh, not 11. Good catch there. 11/3. Ooh, this is supposed to be x, not 3x. Sorry, guys. Alright. Why don't you try one? I'm not going to try and graph this out on my own, guys. But I will give you the graph of this one. That is if I do it right. Alright, how about I fool you a little bit. 4 is greater than or equal to negative x plus 2 is greater than negative 2. Why don't you pause the video, try to work this out by yourself, and graph it, and then come back to me. But I will tell you, I will ask that you keep it as a formal inequality. That means don't separate it with and make sure that all arrows for the symbols are pointing to the left. Okay? So take a break, work this out. Okay? Go on. Okay then. So, we have our inequality here. 4 is greater than or equal to negative x plus 2, which is greater than 2. Simple, guys. Subtract 2 on both sides. Did not mean to press the brightness button. Negative x is greater than negative 4. Divide each side by negative 1. Remember the catch? Yes. Flipping the symbols still exists when multiplying or dividing by negative numbers. Negative numbers. Numbers. So anyways, here's our solution here. Solution here. Pretty weird looking inequality, huh? Really, it's not. It's pretty much the exact same inequalities that we've been trying to solve since the beginning of this game. Alright. Now I'm going to show you my graph. Negative 2 is less than or equal to x. It's less than 4. So let's try it. Alright, that was a terrible number line, but it's gonna have to do. So we put a closed circle at -2 and an open circle at 4. Shade everything in between. And there we go. That's how you do it. And now for a final concept. Actually, we got 2 more concepts, but one more concept where you're going to have to be doing some practical work. Okay? So, we're going to do OR inequalities. Alright? So how about 3x minus 4 is less than, let's say, 8. Or -2x plus 4 is less than 16. So how do we solve this? Well, in order to get the solution, we must simply solve each inequality. So we're going to add 4 to each side for this inequality. We should have 3x is less than 12. Subtract 4 on each side, we should have -2x is less than 12. Less than 12. For this inequality, divide each side by 3. We should have x is less than 4. For this one, we divide each side by -2. Remember to flip the symbols. We have x is greater than 6. Now, despite how easy this is for you to graph, I'm not going to try and graph this. I'm going to see if you can try to figure this one out on your own first. Alright? Alright? Now, I'm going to try and give you something that might throw you off a little bit, but if you really pay attention to what's really going on here, you should be able to figure this one out easily. Alright? So how about I give you something like this? Alright, so it's 4x minus 3 is greater than or equal to 4x plus 4, or 3x is less than 6. Why don't you pause the video, try to work this out, see if you are able to graph this, and then come back and check in with me. Okay, so we got 2 different inequalities joined together by the word OR. We have 4x minus 3 is greater than 4x, equal to 4x plus 4. Notice what we got here. Oh dear. We got the same similar coefficients. So what happens when we subtract 4x on each side? Uh-oh. That's not right. That's not a true statement. Well, if it's not a true statement, that means for this inequality, there are no solutions. However, just because there are no solutions on the left side, that does not mean we don't have any solutions for this side either. Because we can still divide this by 3 on each side. We get x to be less than 2. So really, one part of the compound inequality was just a waste, but the other needs to be kept. So remember, guys, one thing that you try to solve does not always affect how the other might be solved, okay? So really, this right here is our only solution. It's our only solution set. So this will be easy to graph, guys. So it's less than 2. We draw an open circle and shade to the left. Alright guys, that's it. Now, I wanted to give you some extra insight on solutions to compound inequalities. So, let's say you have something that looks like this. Alright, do you think you can graph this? No, you can't. Because x has to be greater than or equal to 3. But it also has to be less than 2. But 3 is greater than 2. Do you really think you can graph that on the number line? No, you really can't. Because, well, the right side of the inequality is shaded to the right, and the left side of the inequality is shaded to the left. They go in opposite directions and do not overlap. And inequalities require an overlap in order there to have a solution. So there are no solutions here. Here. Now what if you had something like this? This. Remember what I showed you with, I think it was this inequality here. Or inequalities do not require an overlap. However, the graphs of these do overlap. And so there just so happens to be infinitely many solutions here. Alright. So that's it, guys. Pretty interesting topic here. Hope you guys learned this well. You are going to need this skill for our last section on linear inequations and inequalities. Yay! So after this, we get to go on to linear functions. Yay! And yay! Anyways, absolute value inequalities. That is our last section. Hope you guys learned well in this video. Be sure to leave a like and subscribe to my channel for more videos. If you really like this video, tell your friends. I want to help out as many people as I can. Okay? So take care of yourselves and have an amazing rest of your day. Alright, so long folks.